so this first link is going to be called Extra Help 03. I'm going to put it in our Extra Help folder. Not the recordings, because I'm making it right now, but the notes. So I'm going to call this 04 Distance Part 1. Refresh your page in the Extra Help folder, and everyone should have this link, 04 Distance Part 1. It's going to give you a practice problem. Now, if it's too small to look at, just click the title one more time, and then you get the big version, bigger. And zoom in. And I'm going to have the student read the practice problem for us. Start with Francisco. Go ahead and read the practice problem. Suppose. The practice problem. The top. Yeah, go to Schoology, day 15. Good. Following. Period 2. Period 2. Sorry, period 4. Oh my God, period 4. Go to period 4, go to day 15, go to Extra Help, and then click on 04 Distance Part 1. 04 Distance Part 1. Yeah, suppose.
Suppose that a ball is dropped from a tower 70.0 meters? Right?
Yes, meters, correct.
And that's this whole thing.
The whole thing.
How far will it have fallen after 1 second, 2 seconds, and 3 seconds?
Neglect.
Neglect. Air.
Resistance, good.
Suppose a ball is thrown downwards with an
Initial.
velocity of 3 milliseconds instead of being dropped. What then would be its position after 1 second and 2 seconds? What would the speed be after 1 and 2 seconds compared to the speed drop of a drop ball?
Look at all those values, okay? If you weren't in this class, it would be very difficult to figure out what is this question asking for, and what do I do with this information? It's a lot. So let's take it one piece at a time. So let's ask Angel, what's one of the numbers that we could probably connect to a variable? Take a good guess. Pick a number and give it a variable. What do you think? And what does that equal? Most likely. Well, what comes after the 3? Well, there's no ms. If it was ms, milliseconds. Seconds. So what kind of measurement is that? Is that distance? Is that time? So t equals 3.00 seconds. I learned in period 1, students get confused by the units and the variables. Like they're using them as the same idea. They're not. Seconds are for time. Okay, let's do another one. Emiliano, give me another number and then let's connect it to a variable. 2. And what's that probably going to represent? Is that going to be time, distance, speed? What do you think? Speed? It has an S after it, so that could mean speed. Angel, what does S stand for? Seconds, which is what kind of variable? Is seconds for speed, distance, or time? Seconds, like 1 second, 2 seconds, 3 seconds. Time. So that's going to be another T. Well, that's confusing. We have 2 T's. What should we do, Michael, to make... Oh, Michael, you were absent, right? Yeah. Okay, you're watching the video? Okay, so let's see if you can get access. let's make the video a Google Drive link. So what I don't like about Google Drive links is that it's gonna not give you subtitles. So we'll call this physics video recordings. It worked? Fantastic. Okay, so give that a try, and then if you still need like more support, then let me know, because we're gonna have like a bunch of tutors ready for you. Okay. All right. So that is Michael's. That's what Michael's doing. Juan, give me another number and another variable. Oh yeah. So there's two t's, Juan. What are we gonna do? When we have an equation, are we gonna put both numbers? What should we put here that will let us tell the difference between the two? T2 and T3. Why not T1 and T2? Why T2, T3?
1 second time to get 4.3.
Everyone hear that? 1 second is the first time. So now we have 3 times that we have to plug into an equation to solve for whatever this problem is asking for. And Alexander, what is this problem asking for? What is this problem asking for? If we look at number 1. How far? What kind of variable represents far or distance? A D or an X, or there's 4 possibilities. It's very annoying. It starts with the first letter of length. L. Yeah. And then if we start dealing with circular areas, it's going to be R. Okay. We apologize in advance. Right. It's not my idea. It's coming from above. Right. Okay. So which is it? X, D, L, or R? Well, it depends on the equation we use. And the equation we're going to use is part 2, part 1. This, X, write this down, X final equals Xi plus Vi T plus. Now when you do your T's, don't make them like a normal T, because it looks like a plus symbol. You will get the heck confused out of it. So put a little curve so you know it's like a T, and then the straight lines are your pluses. And then half a t squared. So zoom out. Now in period 1, a student said, why did you put 1/2 at 2? And that's a common, I mean, that's understandable, right? Maybe this says at instead of a times t squared. But since we're here together, I'm going to clarify a times t is not at. It's acceleration times time. So make sure you made a note of that if you have to. And let's plug in. And if you're wondering where did we get this equation, this is the equation we're going to use for this problem. Okay? This is the equation for the study guide problem. This is the equation for the exam problem. You don't have to wonder which equation do I use. Your notes specify it's this equation. Okay? So that's just one less thing you have to figure out. All right. We're going to solve for x, because that's what Alexander said is one variable for distance. So let's do T2 first. So xf equals xi. We don't have an xi. What should we do, Francisco, if we don't have an xi? Let's look at the problem. Drop from a tower. What does xi represent? Any idea? You know what the I could represent? It could represent initial. How many of you knew that? I is initial. Okay, good. Then what's F? Final. Make a note. Little I is always going to be initial. Little f is always going to be final. If we don't have those little f's and little i's, we don't know which x we're going to use. We don't know which v we're going to use. So Alexander, if xi is initial distance, what number should we put for it? The ball is at the top of a building, not moving yet. 0. So far, almost every xi that we've done in this class has been 0. Very nice. Okay? It's very nice. But sometimes it won't be. Okay? And we'll get to it when we get to it. For now, this wonderful number makes math so easy because anything times 0 is 0. So here we have xi. Let's plug it in. So for xf, we put in 0. And then we have a vi. Angel, what does vi stand for? Velocity, and then the initial velocity. So what is the speed of the ball at the beginning of the problem? Well, look, the ball is dropped from a tower, so it wasn't moving in the beginning. What should we put? 0. Very good. So let's put vi equals 0, and then plug in 0 for vi. All right, Emiliano, what should we put for t? 1. He looked at either T1, T2, or T3. We're going to do T1 first. But we're not done. Half times A. Let's go to Juan. What does A represent? It's how fast something speeds up or slows down. Group? Anyone know? Close. Go ahead. What does A stand for? No, what is the word? Does that sound familiar? Okay, make a note. A stands for acceleration, and then we're going to write down what that is. What is the acceleration of things that fall? Well, it's not given to us in the problem. However, in physics, there's always an acceleration we can use, and that is gravity. Gravity is always going to be a number that you use every single time. That's the same number. Do any of you know what that is? Go ahead. Good. Negative 9.8. Why is it negative 9.8? Because it's falling down. If anything goes back to Earth, scientists have all agreed, all the millions of scientists have agreed it's represented by negative. Instead of saying, this object's falling down, just put a little negative on there, and now everyone knows it's falling down. Negative also does something for horizontal speed. Later on, you'll see we have a car problem that's crossing an intersection, or a car that needs to stop. And a negative number will also be used, but we'll get to that when we get to it, okay? So negative 9.8. So let's plug that in for our first T1.
That's a plus next to the half? Or
Yes, yeah. We're taking this and we're translating it down here, plugging in the numbers. And then T, let's go to Angel. What's T? What should we put after negative 9.8? Or what do I put after this? If I'm carrying everything down here. Do we know what T is? Yeah, but which time are we going to use? Because Emiliano got us started. He said use T1. So should we plug in 3? We have to put in the same time. T1. So T1. And it's squared. Let's do the math. XF. Actually, we're going to run out of room. So I want us to do this on our calculators. So Alexander, grab a calculator. Anyone need a calculator? All right, here you go. And then you need one. You got one? All right, Alexander, give us 0 plus 0 plus half times negative 9.8 times 1 squared. Negative 4.9. That's how far the ball will fall. Negative 4.9 meters. If it's dropped from a building that's 70 meters high. That's our first answer. We have to find 3 answers because the problem asks for T1, T2, and T3. All right, Emiliano, what should we do next? We found T1's distance. What makes most sense to find the next T2? Yeah. So XF equals and tell me what I should put. 0 and then plus 0 times 2 plus half times it's going to be A, negative 9.8, always. It'll be negative 9.8 for your study guide, negative 9.8 for your exam. And your state exam, which is in May if you're a junior. And then what's our last value, Emiliano? What is it? 2. Good. And it's squared. Okay, Juan, calculate. What is 0 plus 0 plus half times negative 9.8 times 2 squared? Half, 0.5. You got an answer? Do you know how to do it?
Yeah.
Negative 9.8 times 2 squared. You're going to do the next one, okay, Francisco? So be ready. Qua, get a study guide. Anyone else done with the practice problems? Come get a study guide. 19.6, negative, correct. Negative 19.6. That's it right there.
Please excuse interruption. Teachers, at this time, please excuse those students that did not get a chance to take their ID picture. Please send them to the social hall with a hall pass. Do not have them take
Oh,
their
you're lucky.
belongings as they will be
All right, you're up.
returning to class. Once
What should we
again,
do
at
next?
this time, teachers, please
We found
release those
the
students
distance
who did
for
not
1
get a
second,
chance to take their
2
picture.
seconds.
Send them to the social
What's next?
hall with a hall pass. Do
Yeah,
not
go ahead.
have them take their
Pictures?
belongings.
Okay, go. Take your pictures. All right, Emiliano. Let's do the next one. What should we do? We found the distance for 1 second, 2 seconds. All that's left is 3. So write XF equals 0 plus 0 times what number, Emiliano? 3 plus half times what? Not just 9.8. Negative 9.8. And then what's the last parentheses? 3 squared. Juan, you're up. Came back too fast. That's correct. Negative 44.1. Very nice. Okay. I'm going to stop the recording.